Hey everyone, Roland this side. I hope you all are doing well. So let's say the problem of the day.
So the problem today we are solving here is the same as tomorrow, but tomorrow we used time complexity as big of n square. Today we are trying to solve it in a linear time complexity that is big of n. So let's see how we are going to solve it. So here's the problem from tomorrow. Okay, so what it basically says, we have to return the number of subarrays that contains majority element. Okay, so for example, we have subarray like something, I mean, 2, 2, 2, and 1. For example, target equal to 2, target equal to 2. So basically, we have to return number of subarray where mm, so basically we have to return number of subarray where majority elements is 2. And what do we mean by majority elements? Then more than half elements should be 2. Okay. So if we consider 2 and 1, it cannot be a subarray with majority element because here the number of target is exactly half, not greater than half. If we take this part, I mean this part, so this is, I mean, can consider as a subarray which has majority element because number of element here is greater than, I mean, number of element here is more than half. Okay, so the total number of element is 3 and number of target equal to 2, so number of target is more than half. Okay, so what basically we tomorrow did is we convert, I mean, so we convert this into all target element into 1, 1, 1, 1, and all non-target element into -1. It could be 3 or 5 something that is not equal to target. So we did this tomorrow, and what we did is if sum of any subarray is greater than 0, okay, so if sum of subarray is greater than 0, it is considered to a valid subarray. Okay, I mean valid subarray which contains majority element as target. Okay, so how this? So if we look at this here, if we consider this, the sum equal to exactly equal to 0, not equal to 0. Okay, so it cannot be a valid. If we consider this, the sum equal to 2. Okay, so it, yes, it is a valid. If we consider this here, sum equal to 1. Okay, 1 and -1 get cancelled out and remain 1. So here sum equal to 1. So it can be a valid. Okay, so that's what we see tomorrow. So what it basically means, so if we apply the formula of prefix sum, I mean, so what was the previous sum of at, for example, let's consider that from here. So at 1, the sum of cumulative sum is 1. At 1, the previous sum is 1 plus 1, that is 2. At 1, 1 plus 1, that is 3. And here it's 2. Okay. So so how this gonna help is, uh, let me write it a bit down. So this is a cumulative sum that we just calculated. Cumulative sum. Okay. And this is the transformed array. Okay, so what we are going to do is, so we just simply have to look if how many numbers that are less than, I mean, okay, hold up, instead of cumulative sum let me do prefix sum. So prefix sum started from 0. So the sum 0, 1, 2, 3 and 2, it's always 1 greater than the actual array. Okay, so the number of the sum of previous element at index 1, so there is no previous element, so it's gonna be 0. At index 2 there is only one previous element. At index 3, the index 2, that is 2 previous element. At index 3 we have 3 previous element. At index 4 we have 4 previous element, and their sum is exactly 2. Okay, so this, yeah, this 2. Okay, so this is the array of prefix sum. So what we are basically going to do is, that's the dummy thing we created, so we simply have to start from here. So we basically have to calculate the number of, I mean, the number of the number of element in prefix sum which is less than the current value, current prefix sum. Okay, so we have to calculate the number of number of previous prefix sum, number of previous prefix sum that is less than number of, that is less than current. So basically we have to calculate the number of previous prefix sum that is less than current prefix sum. Okay. So how many elements are less than 0? So that is 1. How many elements are less than 2? That is 2. 0 and 1. How many elements are less than 3? That is 0, 1, 2, 3. How many elements were less than 2? That is 0 and 1. So that is also gonna become 2. Okay. And if we have something like 3, how many elements are less than 3? 2, 2, 0, 1. That's gonna become 4. Okay. So it's not exactly equal prefix sum. So here we got, okay. So what it basically represents is, I mean, from one, I mean, what it represents. So it's basically represents the previous prefix sum. I mean, previous prefix sum minus current, I mean, current prefix sum minus previous prefix sum equal is greater than 0. Okay. 0 greater than current minus previous. So total number of elements, I mean, where current prefix sum is less than, I mean, minus previous prefix sum is positive. Okay. So if 0 minus 1 is positive, that means this, I mean, for example, here consider if 0 minus 1 is positive. Okay. So from 1, it's gonna be a valid. Okay. It's gonna be a valid subarray. Look here what we did. So this indicates this. Okay. So if we hold on, and 2 minus, I mean, how many numbers are less than, for example, we consider how many numbers are less than 3. That is 2, 1, 0. Okay, so that is 3 numbers less than 3. So if we see at this is 0, 1. So at this index, how many subarrays are possible? This is 1 subarray, this is 2 subarray, and this is 3 subarray. Okay, so that's why 3 subarray possible. If we see from here, there is how many numbers are actually positive. So that is 1, 2, 3. Okay, so that's how we got from this to this. Okay, I mean, we transformed array to the prefix sum. Okay, so here we are calculating the sum of sub arrays should greater than 0. Here we are calculating the, I mean, the in sub array. So if sub array is only valid, so how many sub, here we are directly calculating the number of sub array. Okay, so number of sub array is equal to, for that including that. Okay, so including index 0. So this index 0, this is just a dummy index, we can exclude that. So including index 0, how many sub array is possible? So that is 1 subarray. Including index 2, how many subarray is possible? 2 subarray. Including index 3, I mean, that is index 2, how many subarray is possible? 3 subarray. Okay, including index 3, how many subarray is possible? That is 0, 1, 2, 3 indexes. Including index 3, how many subarray is possible? 2 subarray. So including index 3, 2 subarray is possible. 1, 2. Okay, so that is 1 and 2 subarray is possible including index 3. Okay, so that's what we did. Okay, so how we are basically going to calculate? So one very naive approach is to, we have to look, I mean, stand at index 1. I mean, first calculate the cumulative sum and stand at index 1 and look, iterate over it, how many iterate over it in left. Okay, so in, suppose we are standing at index 3, so we have to iterate over the whole array once again. Okay, so how many numbers to calculate it, how many numbers that is actually less than 3. Okay, we are at, suppose we are at index 2, so we have to iterate over the complete left to calculate the how many numbers that is actually less than 2. Okay, so at index 3 we have to iterate over this, at index 2, that is so that is 2 nested for loop. Okay, so basically it's also gonna give big O of n square almost. Okay, so big O of n square, 2 nested for loop. Okay, so how we are going to optimize this is, we are going to use unordered map to store the number of frequency so that are less than. So we are going to store in a map, unordered map. So what, let's, and let's call it frequency. Okay, so we are going to store the frequency of previous sum, that how many elements are actually less than. So for example, we are at, so first in map we are going to store 0, 1. Okay, so the frequency of 0 is 1, so that's our dummy array. Okay, so starting from 1, how many elements is less than 1? Okay, so if we see how many elements is actually less than 1, and one more thing to add, if we have to calculate number of element less than some x. Okay, so that is equal to number of element that is less than equal to x minus 1. Okay, so for example it's 3, so number of element less than 3 is equal to number of element less than 2, and also 2. Okay, so that's why I put equal to here. So that is equal to number of element less than x minus 1 plus number of element, plus number of actual x minus 1. Okay, so how many number is less than 3? So that's equal how many number is, so we have to calculate how many elements which is less than 3. Okay, so that's number of element less than 3, so that is equal to number of 2 plus number of element less than 2. Okay, so that's the frequency of 2 plus frequency plus number of element less than 2. Okay, so that's how we are going to calculate. Okay, so for example we are at index 1, so how many number are less than index 1? So we are going, so there is only one element, so what is the frequency? So there is only one element. How many numbers is actually less than 2? Okay, so here we are going to use a variable called, valid. Hold on, just let me take valid previous prefix. Okay, so this is a int type, so that's a variable that's gonna count the number of previous prefix. Okay, so initialize it with 0. Okay, so at 1 how many numbers are less than 1? That is 0, so make it 1. So 1. How many number are less than 2? So, and also we have to push in map that 1 occurs 1. Okay, so frequency of 1 is 1. How many number is less than 2? Okay, so that is number of frequency of 1 and number of valid. So we are going to add the frequency of 1 in our previous prefix. Okay, previous prefix is 1, so we are going to add the frequency of 1, that is 1. So 1 plus 1, it gonna become 2. 1 plus 1, it gonna become 2, it gonna remain 1, and also add 2 here. Okay, so at 3 how many, we have to, and valid prefix, previous prefix gonna become equal to 2, and at 3 it will also similarly it gonna become 3. Okay, and store 3 here, and at 2 we have to calculate the prefix. So how many elements are less than 2? Okay, so we will basically count the frequency of 1. So frequency of 1 is 1 plus the number of element less than 1, so that is 0, so that is also 1, so it's gonna become 2. Okay, so we have to subtract it by 1, so that's gonna become 2. So how we are going to do this is, whenever we got a whenever we got a nums equal to target, nums I equal to target, we are going to do the we are going to add that invalid previous prefix. Okay, so whenever it is increasing, look, we got 1 to 2, we got 2 to 3. Okay, so whenever it increasing, the previous prefix is also increasing, so number of valid previous prefix. So basically we are at 3, we got 1 more than the previous. Okay, so if we are at completely increasing, okay, so like 0 1 2 3 4 5, so how many, so at 4 we got 1 2 3 4, 4 valid previous prefix. So at 5 we are going to 1 more including 4, so we are going to include 4. So as we increase 1, if nums equal to target, so it's gonna keep increasing. So why it's keep increasing? Because we got 1 1 1 1 1, So if it's equal to target, okay, so the cumulative sum become this and it's keep increasing. So that's why we are going to simply do the cumulative sum plus plus. Okay, so we are going to, valid previous prefix equal to frequency of previous prefix. Okay, so valid previous prefix equal, frequency of previous prefix. Okay, and then again increase the previous prefix by one. And else, what we are going to do is, also we are going to do decrease previous prefix by one and valid previous prefix plus equal to minus equal to frequency of previous prefix. Okay, and at last, so we are going to do answer plus equal to valid previous prefix and gonna store that valid previous prefix on our frequency. Okay, we are going to store the previous prefix on our frequency. So frequency previous prefix just gonna increase the frequency of previous prefix. Okay, and here we have frequency of 0 equal to 1 because we are going to 0. Okay, so the number of sub, so the count of 0, so the number of subarray where sum is 0 is also 1. Okay, so we are not getting any taking any element. So that's the code, I think so. Yeah, that's the total code. So let's code it and see if it's working or not. So first consider an unwanted map, uh, long called it frequency, and we need valid previous prefix and previous prefix. Okay, so long valid previous prefix equal to 0, long previous prefix also equal to 0, and going to increase frequency of 0, okay, equal to 1. So for int I equal to 0, I less than nums dot size I plus plus, and if in frequency, if nums of I equal to target, we are going to increase the previous prefix, else decrease the previous prefix. So that's basically creating the previous prefix array. Okay, tracking it and increase the frequency of previous prefix. So that's we got a previous prefix. And after that, so what and how we are going to count the number of valid previous prefix that is smaller than, okay, so valid previous prefix, so that is what it initially has plus the frequency of the current previous prefix for here. And here we are going to do this after subtracting, after decreasing the previous prefix. Okay, so valid previous prefix equal to frequency of previous prefix, and at last result equal to result plus equal to valid previous prefix, and also consider long result equal to 0, and at last we simply have to return 0. We return the result. Oh, and if we submit the code and see if it's working or not. Hold on. Okay, some of test cases got passed, and now let's submit the code and see if it's working or not. Yeah, it's working completely fine, and if you see the time complexity here we are using is big of and and space complexity we are using it at worst case it can go up to big of n. Okay, so I think that's it for today. I hope you like this video, so please make sure to subscribe to Tenzor and feel free to ask any doubts if you have in comments. Till then, keep smiling and keep coding.
Baby, it's you and I.